Okay. Two of the most common requirements for any professional application, as it says right here, auditing and concurrency control, right? Anytime you do something serious for a serious client, it's almost always going to involve some level of each, right? Auditing changes to data, right? Now, some systems, I've done some work for, actually a lot of work for credit unions. And believe you me, their systems, they track every change to every piece of information throughout the system constantly, right? Change the spelling of a last name because you made an error earlier on. Well, they know exactly who did it and when, from where in the system, and so on and so forth, right? So, yeah, critical systems have huge audit trails going on before and after values of all fields every time an update is changed. Yeah, believe it or not, the whole previous version and revised version gets saved every single time. Now, we aren't probably going to be doing something quite that extensive at this point in time, but medical systems, banking, financial systems, they often go to that degree of an audit trail. At the other end of the scale, okay, at a minimum, most require at least this basic thing, right? Basic auditing is how we often refer to it. And it comes down to this. Created by, created on, updated by, and updated on, right? Sometimes even just the updated, okay? And they don't even bother with the created. Now, I mentioned that last term when you did some work in your PROG1322, working with databases and learning all about all those good things like triggers and functions and everything, right? You did do some examples where there was updated on and updated by type information maintained and so on. Well, same idea here, these four pieces. So created by and created on, well, that's only ever really applicable, or it'll only ever change one time when the record is created. After that, it's done, okay? You save it for future reference, but you don't really ever change it again, right? Instead, every time an update happens after it's initially created, we note when it happened and who, right? Who is responsible for this update. So we're getting a little bit, so you might ask me, well, how will I know who? Well, we won't know who to blame, who to give credit to for this wonderful change that they made in the database until we actually are tracking who is logged in. It is true that that will come later on in the term, but we're going to have everything ready in our approach to basic auditing, right? So that once we actually are tracking who is logged into the system, we'll be ready for it. Right. In the meantime, we're just going to have to go with a default value, probably of something like unknown, right? Because we don't know who's actually logged in yet. Okay. But we're ready. We're ready to track who's actually doing everything as we go forward. Okay. Now, you've seen other examples where parameters added to stored procedures facilitate the audit process and so on. So, wherever you do the update stored procedure, right, then we pass a parameter and things like that. Well, that's great, right? However, in our approach, using Entity Framework Code first, we're going to implement another approach that is a little different, but it's beautiful. It's beautiful because it's almost fully automates the whole process, right? So once we have it in place, there's almost nothing we have to do to maintain the information and make sure that all the audit information is properly being captured and tracked in the system, right? What we're going to do is we're going to create an auditable class. And any entities that we have in our system can simply inherit from that class, and they'll get all of the fields that are required to do the auditing itself, right? Then, just a few lines of code we're going to add to our DB context can do all the work for us basically automatically, right? It will, through that one choke point, you might say, in the data flow, everything goes through the DB context at the end in order to get written to or saved to the database. So it's a perfect spot then to capture all changes in the data, right? Going to the database, and we can, with a few lines of code there, basically make sure that all the proper audit information is being saved. So it's a very, very elegant solution, actually, is what it comes down to. Okay? All right. So we'll get more into auditing in a minute, but in the meantime, we can also introduce, because it works fairly nicely along beside it, the concept of concurrency control. This too is nothing new, right? You have talked about concurrency control. You've done work with it in the past. Okay, certainly the concept has been discussed in the other courses that you have done, right? The idea here is that if two people are working in the same record at the same time, well, they need to be aware that there's a danger. The danger is that somebody else has modified the information while you've had it up on your screen. Maybe they've made a change then that you're not aware of. In particular, that is very, very applicable to any edits or updating, right? An update operation. If someone else has made a change and then you're going to maybe making a different change, right? You just need to know that the record is no longer as it is as you brought it up on the screen. Let me emphasize that again. It's no longer as it is when you brought it up on the screen. In other words, when you click the edit button, right, and you retrieve the current status of the record, all the information, all the properties are there on the screen for you to see, you're going to make whatever decisions you're going to do, maybe even for a delete, right? Maybe you're about to delete the record. So you look at it all, you say, yep, this is the record we definitely want to delete. But what if somebody in the background, while you're staring at the screen, has made some change that would affect your decision? Or maybe even just with an edit, affect the process. Maybe they edited something and you're about to edit it again, right? Okay, so it's really, really important that, no, we stop the process. Say, no, you cannot directly save your change right now or delete this record because the record itself has been modified by another user while you haven't had it up on your screen and you're thinking about what you're about to do, right? Okay, so that's really the whole idea of what it comes down to, right? The changes you're about to make might be different if you were aware of the changes other people have made, okay? Now, how do we implement concurrency control? Two common methods. Compare all values, right? Compare each and every property or field, whichever term you prefer to use, okay, for the entire row of data or the entire entity and see if anything has changed, right? That clearly would work. I mean, obviously, it has to work, right? And that would be one way to detect a concurrency error, right? Or concurrency collision of changes, you might say. The other very common approach is to use a timestamp or row version, right? Some unique value that gets always changed anytime there's an update to the record, including when it's created, which is a special form of update, you might say, right? So a new timestamp or row version is created, right? And that way, it's much more efficient in that you can only do one comparison. Has this timestamp changed? As opposed to comparing all values, right? Much more efficient that way. Downside is now you're adding an artificial piece of information to the record just for the purpose of concurrency. So you're bulking up the data, a little more data to pass around from one hand to the other as you're manipulating things as well, right? Overall, though, for the most part, concurrency control with a timestamp or row version is much more efficient and certainly easier to program, right? Okay. And on the plus side, SQL Server, okay, Microsoft SQL Server, and pretty much the majority of other databases around the world already have a special built-in field, okay, that will automatically update whenever the record is updated as well, right? So you create a timestamp field in SQL Server, that's it. It just does its thing. Every time you do an update, it generates a new timestamp value. You don't have to do anything for it. However, we are not using SQL Server this term. We're using SQLite, right? The most popular database in the world, and it does not have such a field, okay? There is no automatically updated timestamp or row version field in SQLite. But, hey, I promised they'd pay off. Remember I said one day when you learn triggers down the road, you're going to find a good use for them. Well, here's an example, right? We can create our own triggers, right, to update our timestamp, row version, whichever term you prefer to use, right, to update that every time there's a record is created or updated in our SQLite table itself, right? So that is exactly the approach that we're going to take. We'll take over that aspect of it. So it is still pretty well automatic once we have our triggers in place. After that, things pretty much go as expected, exactly the same way if it was SQL Server or any other database. So here is the crux of it. Where and how do we get these triggers created? Well, roll up your sleeves, folks. Yes, I said we'd be doing most of our work this term with LINQ, language integrated query, but here's a case when we're going to go back to raw SQL commands, right? That's what we're going to do to create these actual triggers, right? We'll execute the commands as we create the database, right? So that's basically the where in our code, okay? How is with raw SQL commands. Where in our code, we're going to add them to where we initially create the database itself. So now you could, like I have a link in my copy paste file for this to one of the very good tutorials out there on implementing concurrency control, where it shows adding the code in an actual migration, right? But an alternate place you could do it, and the one I encourage you to probably put into practice, is put them right in your initializer. Okay, I prefer that method because, as we've seen, we often end up deleting our migrations. If things kind of get messed up or out of sync a little bit, sometimes the best solution is to wipe out your whole migrations folder, delete the database. Remember, we're just in development stage here, right? Then add a brand new migration that basically captures the current state of your model, okay, in one complete migration, and away you go. Trouble is, if you have your code, your SQL commands, the raw ones, right in the migration, and you just deleted it all, right? You got to do extra work to kind of make sure you get it back into place. We avoid that whole issue by putting them right in the initializer. And it's pretty safe to do so, right? We just put it right in our spot. Remember, right in, well, we'll have a look at it in the code, but just here a screenshot. Okay, right after we do the code where we decide are we going to apply migrations or use ensure created, okay, one way or another, we've created the database, right? So it's a good place to add any additional database objects, triggers, views, etc. So that, my friends, is exactly where and how we're going to get our triggers in place. Okay, well, that's just a nice discussion to introduce the topic. And then we're going to go ahead and actually I don't know if we'll get to concurrency, but we should have time today to get through the audible, right? So maybe I'll stop and start the recording just to break it up a little bit.